Alright, the first problem on the worksheet, this is 4.1a, asks you to graph the function y equals 1/3 x squared. So if you remember in class we talked about how symmetry is your friend. So if you can locate the vertex, that's a good first start. The vertex is 0, 0 on this, so let's mark that point here. Now let's look what happens to the right of the vertex. So let's find out when x is 1, when x is 2, and when x is 3. So when x is 1, 1 squared is 1, 1 times 1/3 is 1/3. When x is 2, 2 squared is 4, 4 times 1/3 is 1 and 1/3. 3 squared is 9, 9 times 1/3 is 3. Let's do one more. 4 squared is 16, 16 times 1/3 is 16/3, which is 5 and 1/3. And I lied, let's do one more. 5 squared is 25, 25 times 1/3 is 8 and 1/3. So, talking about symmetry, if I were to plot the point 1, 1/3, that would be right around there. So I'm just going to do that to the left of it. -1, 1/3. 2, 1 and 1/3 is there. -2, 1 and 1/3. 3, 3. -3, 3. 4, 5 and 1/3. -4, 5 and 1/3. 5, 8 and 1/3. -5, 8 and 1/3. So we see the nice shape of the parabola here. So if you tried to connect these all, you get your parabola just looking just like that. And I should mention, the reason why we knew that the vertex was 0, 0 is if I were to write this in vertex form, it would be y minus 0 equals 1/3 times x minus 0 squared. So you see the vertex is 0, 0. The next one, the vertex, if I were to write this in vertex form, I could write it as y plus 3 equals x minus 0 squared. Or I could write it as y equals x minus 0 squared minus 3. So the vertex is 0, -3, and again 0, -3. So that's my vertex. So I'm going to start by plotting that point right here. I'm going to find out what happens to the right of it. So let's do 1, 2, 3, 4, 5. Plug these values in. 1 squared is 1 minus 3, -2. 2 squared is 4, 4 minus 3 is 1. 3 squared is 9, 9 minus 3 is 6. 4 squared is 16, 16 minus 3 is 13. I'm going to forget about 5 because this has already gone beyond the 12 by 12 dimensions that I have. So 1, -2. Remember the symmetry. -1, -2. 2, 1, -2, 1. 3, 6. -3, 6. 4, 13. That would be just above the graph. -4, 13. So connect those. And you have your graph. Number 3, we see that the vertex here is at 2, 5. So I'm going to plot that point, 2, 5, here. Well, let's move that up just a little bit. All right. And from that point I want to find out what happens to the right and to the left of it. So I want to find out what happens at 3, 4, 5, so on and so forth. So let's start with 3, 4, and 5 first. If I plug in 3, 3 minus 2 is 1, 1 squared is 1, 1 plus 5 is 6. 4 minus 2 is 2, 2 squared is 4, 4 plus 5 is 9. 5 minus 2 is 3, 3 squared is 9, 9 plus 5 is 14. So let's do those. 3, 6. Now I'm not going to do negative 3, 6 because the vertex is not when x is 0. The vertex is when x is 2. So 1 unit to the left, I'm going to have an output of 6. So 2 units to the right, I'm going to have an output of 9. 2 units to the left, output of 9. 3 units to the right, output of 14, so way up here. 3 units up to 14. So then you have this graph looking like that. Alright, number 4. They want you to identify a whole bunch of different things. The first thing is the vertex. So the vertex is going to be the opposite of what you see here, which is 3, comma, what you see here, 1. Because the 1 is moved to the right-hand side of the equation. If it was to the left, you would take the opposite of what you saw. So there's your vertex. The next thing is going to be, what is the axis of symmetry? In your notes, you should have the axis of symmetry equaling an equation. The equation is always going to be x equals the x value of the vertex. Because if you want to think about it, let's just take a little graph here. My vertex is at 3, 1, right over here. No matter how I draw it, whether it's down or whether it's up, there's going to be a symmetric axis to the right and to the right and to the left of it. That axis is a vertical line. That vertical line is going through the x-axis at 3, so the axis of symmetry is going to be the equation x equals 3. Next part, is it a maximum or minimum value? Well, look at the value of a over here. A is positive. That means it's going to open up. If it opens up, it's going to have a minimum value. That minimum value will be the k, the output of the vertex. So the minimum value is 1 for this problem. The domain of any parabola opening up or down is very easy. It's the set of all real values. Because you can plug in anything for this equation here, and you're going to get something out of it. You're in no danger of dividing by 0 or taking a square root of a negative. The range, since it's opening up, it's going to be, let's just say it looked like this. It's opening up. It's going to be everything greater than the output of the vertex. I'm not really sure what that noise was, but anyway, it's everything greater than the output of the vertex, because that's the minimum value. So if that's the minimum value, it's going to be the set of all y's such that y is greater than or equal to that minimum value. So that's the range of the function. All right, number 5. Write this equation of the parabola in vertex form. So what we're going to do is we're going to start with vertex form. So y minus k equals a times x minus h squared. And what we're going to do is we're going to drop h and k into our equation. So y minus 5 equals a times x minus 2 squared. We're almost finished. We just need to find out what a is. To get a, we can use this point for x and y and solve for a. So that's the next step. So let's substitute 1 for x and negative 3 for y. So when I do this, I'm going to have negative 8 equals, this is negative 1. Negative 1 squared is 1. 1 times a is a. So negative 8 is a. So what I'm going to do is I'm just going to put this negative 8 right over here, and then I've got my equation. And there's my answer right over here. Alright, so determine a and k so that the given points are on the graph of the function. So this is a lot like the other problem, but for this one we don't know what k is and we don't know what a is, but we do have 2 points that we can put in here. Now because there's 2 points that we're going to be putting in, we're going to have 2 separate equations. So the first equation, we're going to stick 6 in for y and negative 2 for x. And the second one, I'm going to stick 1 in for y and 3 in for x. And then we solve these equations as much as we can. This one over here, if you kind of look at it, 3 minus 3 is 0, and 0 squared is 0. 0 times a is 0. So this whole thing eliminates. So we end up having 1 equals k, which is nice because what we can do is we can stick 1 in for k over here and immediately solve for a. So that's what we're going to do. So 6 equals a, parentheses, this is negative 5 squared plus 1. Negative 5 squared is 25. 25 times a is 25a. And from here I'm going to subtract 1 from both sides and then divide both sides by 25. 5 divided by 25 is 1/5. So we have k and a, and that's exactly what they asked for. Alright, number 7, solve for x. This is a review problem, basic review of Algebra 1. So what I'm going to do is I'm going to distribute 7 into this first parentheses. I'm going to have 7x plus 7. Then I've got minus 3x equals 5. Then I'm going to distribute the positive 4 in. Plus 8x minus 4. Next, I'm going to simplify what I can on both sides. 7x minus 3x is 4x. Over here I have 8x. 5 minus 4 is 1. I'm going to move the x's over here, so I'm going to subtract 8x from both sides. So I'm going to have negative 4x plus 7 equals 1. Subtract 7 from both sides, so I'm going to have negative 4x equals negative 6. And then from there, x equals, I'm going to divide both sides by negative 4. The negatives cancel. I'll have 6 over 4, which reduces to 3/2. Alright, this one's an absolute value inequality. I'm going to split it up, which is what you do with absolute value inequalities. The first equation is exactly how you see it, but just without the absolute values. The second equation is exactly how you see it, and then the flip and switch. You flip the inequality sign and you switch the sign of whatever's on the right hand side. Now because the absolute value was isolated, I didn't have to do any first steps in terms of isolation. It's already isolated. So I can read the inequality sign. It's a greater than sign. That means it's going to be a union. That means it's an or statement. If there was something on the outside of this absolute value sign on the left-hand side, I'd have to isolate it first before I break it up into two inequalities. So let's solve these individually. Negative 2x, I'm going to subtract 1 from both sides. Then I divide by a negative 2. When I divide by a negative, I flip the sign. So x is less than negative 1/2. Over here, negative 2x is less. I'm going to subtract 1, so negative 3. Then I divide by negative 2, so I flip the sign because I'm dividing by a negative, and I get 3/2. So when I have my number line here, so I've got 0, negative 1, 1, and 2. So when I do this, its x is less than negative 1/2, which would look like that. It's open circle because it's only less than, not less than or equal to. Or x is greater than 1.5, so it would be that. Now my final answer is going to be the combination of both of these. I'm going to take both of them. I'm not going to take what's in common. Well, there's nothing in common, but if there was something in common, I wouldn't take only what's in common because it's a union. It's an or statement. If it was less than up here, then I would only take what's in common. But I'm going to take it all. So I'm going to take all of that and all of that, and that's my answer. All right, number 9, point-slope form from these two. So point-slope looks like y minus y1 equals m times x minus x1. That's review. So what I'm going to do is I'm going to find out what the slope is first, because I'm given 2 points, so might as well, right? So the slope is going to be y2 minus y1 over x2 minus x1, which is negative 6 over negative 6, which is 1. So there's my slope. Oops. So my slope is 1 here. So I have y minus y1 equals 1 times x minus x1. Or you could have just gotten rid of m. Now the question is, which one of these points do I decide to stick in for x1 and y1? Well, the answer is you can choose either one of them. You can get the right answer regardless. So you have two answers. You could have y minus 4 equals 1 times x minus 1. That's one acceptable answer. Or you could have y plus 2, because I'm going to be sticking negative 2 in for here, and y minus negative 2 is the plus 2, equals 1 times x minus negative 5, which is x plus 5. So either of those are correct answers. Last but not least, we have a written out problem. It's asking you to write out an explanation describing how do you tell if a parabola opens, well, how do you tell if it has a minimum or maximum value? Well, you can tell by examining the a value of the parabola. In general, if a is greater than 0, then it's going to have a minimum value. And the reason why is because if a is greater than 0, it opens up. And a parabola that opens up bottoms out. This vertex is the very lowest. It's the very lowest. Is this the right word? It's the lowest value that you're going to have. And there's an announcement. Okay, and if a, and there's the bell for first lunch, if a is less than 0, then you're going to have a max value. the max value. Because if A is less than 0, it's going to open down. If it opens down, it tops off over here. So you would just explain that in words. And that's it.